Hello, Integrated Math 1. Welcome to lesson 1.2.3c. We're finishing off all of our work with our recursive and explicit formulas and expressions, just making sure we got it down. So we don't have a warm-up for you today. That's all right. We finished the warm-ups earlier. It's just because we're good. So just a few little reminders, our learning goals. You've learned how to write recursive formulas for both arithmetic and geometric sequences, but the real golden child, you learned how to write explicit expressions and formulas for arithmetic and geometric sequences from contacts. Those are the magic ones, right? Those explicit formulas, those will help you find any term. You do want to make sure you know if it's arithmetic or geometric, because we saw the formula changes pretty drastically depending on which one of these are. So we're going to keep using these formulas to determine unknown terms of our sequences. You guys have been doing great so far. So those key terms, recursive formula, explicit formula, of course, we talked about how the recursive formula just helps us find the next term, but the explicit formula helps us find any term we want. I love it. So we've been writing equations to represent these arithmetic and geometric sequences as functions. You've been doing great with these. Now, we're going to go back. Remember how we had our little sequence cutouts and our little graph cutouts? Do you remember that? And we identified our sequences as arithmetic or geometric, and then we matched them with the graph and we put them in the little organizers on pages 117 to 127. Do you remember that? We're going to go back to those pages because we haven't finished yet. We glued in our sequence, we glued in the graph, but down below it says recursive formula, explicit formula. We're gonna fill in the formulas, yeah! So all I want you to do is to go back. Remember these pages? Yeah. So starting on page 117 and all the way to page 127, all I want you to do is write in your recursive formula on the bottom left, write in the explicit formula on the right. Please pay attention whether it's arithmetic or geometric. Please keep in mind that you know what your common difference is, you know what the first term is, so you do know some of the things that you can plug into these. So go ahead and hit pause, fill them all in, and then hit play when you're ready to check your work. So this probably took you a while to fill in. That's okay. If it took you a little bit, that's okay. So let's start with this one. I'm starting with sequence B. You might have started with a different sequence. Yours are probably in a different order than mine. That's okay. It's okay if they're in a different order. So just find your sequence B and let's write our formulas. So the recursive formula we said was a sub n equals a sub n minus 1 plus d. I do know what d is. This was doubling, right? We wrote down d equals 2. So I'm going to say the formula is a sub n equals a sub n minus 1 plus 2. Back in the dark. There we go. I just need to do a little move. Explicit formula, though, that one got a little more detailed. That's okay. I'm going to fill in what I know. I know the first term was a negative 4, right? That's where it started, was negative 4, plus my common difference 2. I don't know which term, so I'm just going to leave it here as a formula. So for sequence E, recursive, again, just means I'm going to do my a sub n equals a sub n minus 1. And then, of course, our common difference was a negative 9/4. So I wrote minus 9/4 instead of plus this time. For my explicit formula, I also needed to plug in my first term. So my first term was 4 minus 9/4, because that was our common difference, times n minus 1. More arithmetic sequences. I'm on sequence H, so make sure you find your H. That means my recursive term is a sub n equals a sub n minus 1. Ooh, common difference is 4, so plus 4. My explicit formula then is going to be my first term, negative 20, plus my common difference 4 times n minus 1. Yay. For sequence K, I can already see my common difference is a negative 1.5. So I'll say the recursive formula is a sub n equals a sub n minus 1 minus 1.5. And I'll say that my explicit formula, my first term was 6.5. So I'll say my explicit formula is 6.5 minus 1.5n, because that's my common difference, times n minus 1. My last arithmetic one, this one got crazy, but we could see the common differences in negative 20.5. So for the recursive formula, we have a sub n equals a sub n minus 1 minus 20.5. For my explicit formula, I have to include the fact that my first term was 1,473.2. So here's my first term minus 20.5 because that was my common difference times n minus 1. So you've got all of your arithmetic ones. Hopefully you're still with me. Hopefully you're still doing okay. Let's do the geometric ones. Yeah. So let's come over here to our geometric guys. So for our geometric sequences, let's see, our ratio was 2. So I'm looking at sequence A where our ratio was 2. So find g sub n equals g sub n minus 1 times 2. Please remember we're multiplying now. It's geometric. Which means new geometric formula, my explicit formula for geometric sequences. So my first term was 45. So I have 45 times my ratio 2 raised to the n minus 1 power. Let's do C. Sequence C. I can see my ratio is 3. So my recursive formula is g sub n equals g sub n minus 1 times 3. But that means my explicit formula also has to use my first term. My first term was a negative 2. So I have g sub n equals negative 2, my first term, times my ratio 3 raised to the n minus 1 power. My next geometric sequence that I have, again, yours might be in a slightly different order. My next geometric sequence is f, and I can see my ratio is 0.1. We wrote that down earlier. So fine, my recursive formula is g sub n equals g sub n minus 1 times 0.1, which is great if you want the next term. But if you want any term, we'll go with the explicit formula. So I need my first term, 1,234, times my ratio 0.1 raised to the n minus 1 power. More, hang on. Sequence J. Ooh, my ratio on sequence J was 1/2. So my recursive formula, just to find the next term, is g sub n equals g sub n minus 1 times 1/2. Okay. But the explicit formula was the magic one. So for my explicit formula, my first term was a negative 5. So fine, I have g sub n equals negative 5, my first term, times my ratio 1/2. And because it's a fraction, I went ahead and put it in parentheses to make sure the whole fraction got in there. Raised to the n minus 1 power. Awesome. Two more, right? Dos más? We're so close. For sequence M, I can see that my ratio is negative 1/4. So for my recursive formula, I have g sub n equals g sub n minus 1 times negative 1/4. Again, I'm using parentheses because that got crazy. And that means, though, the magic, of course, is the explicit formula that can find any term. So I need my first term, which is a negative 16. So fine, my explicit formula is g sub n equals negative 16 times negative 1/4, all in parentheses to keep it all safe, raised to the n minus 1 power. And my last sequence P. My ratio was a negative 3, so fine, my recursive formula is g sub n equals g sub n minus 1 times a negative 3. I got to use the parentheses so that the negative doesn't get lost. It's a thing. But if I want any term, not just the next term, if I want any term, I'm going to use my explicit formula, which means I need my first term, which is a negative 4. So negative 4 times my ratio negative 3, parentheses, keep that negative safe, raised to the n minus 1 power. Whew. That was a bit much. But we now have formulas for everybody, right? And now you should be pretty darn comfortable with these recursive and explicit formulas, especially the explicit formulas. We've used it a lot because they're magical. As always, guys, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, you can email me, come see me during office hours, come talk to me after class, lunch, break. I'm around, and I'll see you guys later. Bye.